All right, let's look at negative exponents now. And I just wrote these exponent rules from the previous page here for easy reference because we're going to be using them here. So what we want to think about is what does something like 2 to the negative 3 even mean? Um, it doesn't really make sense as repeated multiplication. Like, how can you multiply 2 times 2 times 2 with like negative 3 copies of 2? So whatever it means, it would be nice if the exponent rules from the last page still worked with negative exponents. Because we're going to make this mean something, but we want to make it so these exponent rules still work, even when the m and the n here could be negative numbers. So let's see what happens with these examples, trying to just use the exponent rules. Even though you can't write x to the negative 3 as repeated multiplication, like x times itself negative 3 times, we can still use one of these rules. And because this is x to a power times x to a power, they have the same base of x, you can use rule number 1 here. So this is going to become x to the power negative 3 plus 5. And negative 3 plus 5 is 2. So this should be x to the power 2 using that exponent rule number 1 here. How about y to the power 4 divided by y to the negative 2? Okay, well, this is the same base of the exponent y in the top and bottom of the fraction, and with different exponents there. So the one that works there is rule number 2. So it's going to be like a to the m minus n, but with y instead of a, and 4 instead of m, and negative 2 instead of n. So that would be y to the 4 minus negative 2. And 4 minus negative 2 is just 4 plus 2. So that's going to become just y to the power 6. If these exponent rules actually work with negative numbers. And hopefully they do. How about with this one? So w to the negative 2 you can't write as repeated multiplication, and then negative 6 you can't write as repeated multiplication either, but you can use this rule number 3. You have an exponent in parentheses raised to the power of another exponent. So this says instead of m we have negative 2, instead of n we've got negative 6, so we can write it as w to the power negative 2 multiplied by negative 6. That's like the m times n. Okay, and negative 2 times negative 6 is positive 12. So this is just w to the power 12. Interesting. Okay, so that's the way these would work out if you are allowed to use these rules. So let's look at this from another angle now. We're going to figure out what a to the negative n means here, but to understand it better, let's fill in this table so that there's a consistent pattern. So I'm going to start with the ones that we know. Like 2 to the power 1, that just means 2. 2 to the power 2 means 2 times 2, which is 4. 2 to the power 3 means 2 times 2 times 2 times 2, which comes out to 4 times 2 is 8. So this is 8. 2 to the power 4 means 2 times 2 times 2 times 2. So it's 4 times 2, which is 8. 8 times 2 is 16. So those are the ones that we know. And you notice the pattern is every time the exponent goes up by 1, it's like multiplying the previous one by another 2, right? So like 2 to the 4 is 2 times 2 times 2 times 2. It's like this part here is like 8, and then if you multiply that by 2 again, you get to the power 4. So in other words, every time you go to the right in the table, you're multiplying by 2. Okay, so let's try to make that keep happening here. So that every time you go to the right, there's a consistent pattern. You just keep multiplying by 2. Well, what is it that you can multiply by 2 and get 2? So whatever goes here is going to be something you can multiply by 2 and get this result of 2. How about 1? 1 times 2 is 2, so this could just be 1. Okay, and what will go here? Something that you can multiply by 2 and get 1. Let's think. What would go here? How about 1/2? 1/2 times 2 is 1. So this is going to be 1/2. And you maybe can see that like going backwards here to get these is the same as dividing by 2. So I think that's another way to look at it here, is say from 16 to 8, you're dividing by 2. From 8 to 4, you're dividing by 2. 4 to 2, you divide by 2. 2 to 1, you divide by 2. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. Okay, so 1/8, by the way, the 8 is the same thing as 2 to the power 3. So you could write this as 1/2 to the power 3. And 1/4, the same way, you could write that as 1/2 to the power 2. So maybe that shows you what you can do with these negative exponents. 2 to the negative 2 means, well, there is repeated multiplication by 2, it's just in the denominator of the fraction. 2 to the negative 3 means 1/2 to the power 3. So that's what a to the negative n in general will mean. 1/a to the power positive n. And a to the power 0 is just going to be 1. Okay, so that is our definition of negative and 0 exponents. All right, so let's keep going with this. Let's try to simplify these using this definition. So this time, instead of using the exponent rules, we're going to use this definition to turn x to the negative 3 into like a fraction. And these are the same expressions as example 1 here. Let's make sure it works out the same way. So x to the negative 3 using this definition means 1/x to the power 3. We have that times x to the power 5. And what can you do with that? Well, you could combine these. Remember that like x to the, like something that's not written as a fraction, you can imagine it's like over 1, and just multiply the tops together. So you get 1 times x to the 5 and x to the 3 times 1 in the bottom. And then you could use the rule number 2 here, where you have the same base, which is x in the top and bottom, but different exponents. So this would turn into x to the 5 minus 3, which is x to the power 2. And is that what we got before doing the same problem here? Yes, it is. Okay, let's try the same thing with this one. So that y to the negative 2, I'm going to leave it in the bottom of this big fraction, but write just the y to the negative 2 as 1 over y to the power positive 2. So now you're thinking this isn't really any simpler. How are we going to simplify this? Well, there's a trick. If you have a fraction within a fraction, you can multiply the top and bottom of any fraction by the same thing. You're always allowed to multiply both sides by anything. And I'm going to multiply both sides by y squared because 1 over y squared times y squared just cancels out and leaves you with 1. So in the top, you have y to the fourth times y squared. And in the bottom, you just have 1. And what's y to the fourth times y squared? Well, you can think of it as repeated multiplication, as y times y times y times y 4 times y times y 2 times, which is a total of 6 y's, is a good way to think about it. You could also use exponent rule number 1 here for that, and add up to 4 plus 2. Either way, you get y to the power 6. And is that what we got before? Yes, it is. All right, so now w to the power negative 2, and then that to the power negative 6. Well, let's see. I'm going to write I'll start with the w to the power negative 2. I'm going to write that as 1 over w to the power 2, positive 2, which is what this rule says. And then that's now to the power negative 6. And then what do I do with this negative 6 exponent? Well, I'm going to still use this rule again. It's just instead of a, we now have this whole thing to the power negative 6. And so this is going to turn into 1 over that a to the power positive 6. That's what this rule says to do. Okay, so now what do we do with that? Well, if you have a fraction raised to the power 6, which rule can you use here? That looks like rule number 5. I can do 1 to the power 6 here. Over w squared to the power 6. And 1 to the power 6 is just 1. And w squared to the power 6, that's a power to a power. The rule says that you multiply those exponents to get w to the power 12. So this is 1 all over 1 over w to the 12th power. So it's a fraction within a fraction again. I'm going to simplify it by multiplying both sides by the denominator to cancel out that denominator there. So that cancels out, you just get w to the power 12. And that's what we got before. So anyways, doing it this way is a little bit more complicated, but the point I'm trying to make here is that if you use this definition, all of these shortcut rules that we have still work, even when the m and the n are negative numbers. So that is pretty cool. We're making the universe of mathematics that we can do a little bit bigger here by using this definition. Okay, so let's do example 3 here. So this is where we have kind of somewhat more complicated expressions here, and we want to practice using the rules that we know, and maybe using the definition here to write these in a simpler form with no negative exponents. So let's start with A. The first rule that applies here is just the regular distributive rule, because you have 3 terms on the inside of the parentheses, and then something multiplied by that whole result. You can just distribute that r squared into all of this. So that's going to give you r squared times 3 plus r squared times r to the negative 1, then minus I'm going to write this as 4 times r to the negative 2, and then that times r squared. So just multiplying each of these terms by r squared. All right, now how can you simplify each of these? Well, 3 times r squared you can't really do anything with. That's just 3r squared. R to the 2 times r to the negative 1, that's the same base of r in both of those in different exponents, so you can add the exponents. So this should turn into r to the power 2 plus negative 1. This one's going to be the 4 you can't do anything with. That's just going to be minus 4. And then we have r to the negative 2 plus 2. You can add those exponents. So let's do that here. 2 plus negative 1 is going to be 1. So that's just r to the 1, or just r. And then over here, negative 2 plus 2 is 0. So this gives you 4 times r to the power 0. And what's r to the power 0? Anything to the power 0 is just 1. So I'm going to rewrite this as 3r squared plus r minus 4 times 1, which is just 4. So that's simplified, and we've got no negative exponents. Okay, how about b here? 2/3 to the power negative 1. Well, let's see. There's a couple ways you could approach this. I'm going to start by using the definition of this negative exponent. You got a negative 1 there, and the a is like 2/3. So using this rule, I'm going to write it as 1 over 2/3 to the power positive 1. And 2/3 to the power positive 1 is just 2/3. So this is just 1 divided by 2/3. I'm going to multiply both sides by 3. You can always multiply both sides of a fraction by the same thing, and that will cancel out that 3. And this leaves you with just 3 over 2. So you notice that making this be to the power negative 1, in the end, it kind of just flips over the fraction. You can think of it as just 3 to the 1 over 2 to the 1. It's kind of a shortcut rule you can use. Okay, how about this one? Let's see. If I wanted to apply a rule to this, let's see, you have something in parentheses with multiplication here, and then it's all raised to the power negative 3. Which one of these rules applies to that? If you're saying rule number 4, excellent. Yeah, this is rule number 4. So instead of a and b here in rule number 4, we have 5 and x to the negative 2. So we're going to do 5 to the power negative 3, and then x to the negative 2 to the power negative 3. Okay, so what can we do with this? Well, 5 to the negative 3, you can use the definition to rewrite that as 1 over 5 to the power 3. And x to the negative 2 to the negative 3, that's a power to a power, so rule number 3 works for that. We're going to multiply those powers to do x to the power negative 2 times negative 3 in the exponent, which is just going to be x to the 6. So we have 1 over 5 to the power 3 times x to the power 6. You can pretend this x to the 6 is like x to the 6 over 1, and then multiply these fractions together. And you'll get x to the power 6 over 5 to the power 3, which is 5 times 5 times 5, which comes out to be 125 times 1. Okay, so this is all simplified with no negative exponents. All right, up next you have some exercises to do. So I'll talk to you in that video. Keep up the good work, and take care of yourself.